So a very good morning to everyone. We are from the Department of Electrical and Computer Engineering. So my name is Arthur. I look after our outreach program over at our department. So for this morning, we'll have many people here to share with us the different programs that we have. Prof. Tam Cheng Kong, who looks after our undergraduate program, he will share about the electrical engineering program curriculum. Prof. Birdie, who is the chair of the computer engineering program, he will help to share about the computer engineering program and the things that our computer engineering student does. Dr. Chua Ting Chen, who looks after student life, will share about some of the vibrant student life that we have over here. Something very unique, like we have our own undergraduate students council. And then we have two students here that will be sharing with us today. Hui Yu from electrical engineering and Yu Jie from computer engineering. And then finally, we have one of our alumni here this morning. He's Terence Neo, and he will share about some of his experience after working, right, and how the electrical engineering program has helped him. So these are the panelists that I've just mentioned just now, right? So our head of department, Prof. Y. Si Liang, is also here with us today. And then among our students and alumni, so Brian is here. He's from electrical engineering. He stays at Raffles Hall. Hui Yu stays at Yusof Hall and is doing a minor in sociology. So maybe if you have questions regarding minor, you can ask her as well. Isabella stays at Richfield Residential College, and she's with the Bumblebee team, right? So afterwards, we'll briefly mention about the Bumblebee team, and for those who are interested, you can ask her question as well. And then we have Yu Jie over here, who used to be our previous USC president, and he's also from the computer engineering program, and he'll be sharing with us this morning. And finally, like what I mentioned, Terence is here. Okay, so before I start, I want to show you a video that will explain what is electrical and what is computer engineering.
Electrical and computer engineering encompasses a range of fields that form the backbone of our modern digital economy. At NUS, we offer 2-degree programs in electrical and computer engineering. Students on both programs get to work on projects covering themes from Internet of Things and autonomous systems to energy sustainability and smart healthcare. Some students have even designed and built satellites that have been actually launched into space.
From the processors that power our mobile phones to autonomous vehicles and augmented reality, electrical and computer engineers are behind the most transformative innovations. Electrical engineers create technologies from tiny microchips to electric vehicles to nationwide power grids that use electricity and electromagnetism. Computer engineers build intelligence into ever smaller, smarter, and more powerful devices that enrich modern life.
At NUS Electrical Engineering, there are a lot of opportunities for hands-on learning. For example, the lab modules in which we build and experiment with electrical circuits really help me understand and appreciate the theory. There are also a lot of opportunities to learn different coding languages, skills that are highly sought after by employers.
NUS ECE offers many focus areas for you to develop your strengths and interests. For 2 years, I was president of the ECE Undergraduate Student Council. There, I developed my leadership abilities, organizing school events such as the internship and career fair. Through the modules I've taken, I've learned various skills critical to the AI field, such as machine learning and natural language processing. These skills are highly relevant in the career that I'll be pursuing after graduation.
At NUS ECE, students plan their education to match their interests and career aspirations. We combine a strong emphasis on learning the fundamentals with a high degree of flexibility, mixing education, business, and research opportunities. Our students can also embark on various industry tracks and specializations, from AI and data engineering to robotics, as well as in exchange programs and entrepreneurship opportunities at NUS overseas colleges. Electrical and computer engineering opens up a world of discovery, preparing you for careers that are full of exciting challenges. ECE graduates work in fields such as research and development, design, manufacturing, banking, management consulting, and software development. Some alumni have even launched their own businesses that find innovative ways of applying electrical and computer engineering technologies.
Our programs are designed to develop versatile engineers primed and ready to work at the cutting edge of the digital economy and the smart nation. Join us for an inspiring university experience, preparing you for an exciting career that innovates for the future.
Okay, I hope this video will give you some brief idea of what we are doing over here in this department, and the speaker next will then go into detail on the different programs. So as mentioned, over here at Department of Electrical and Computer Engineering, we offer two full-time undergraduate programs. One is the Bachelor of Engineering in Electrical Engineering. The other one is the Bachelor of Engineering in Computer Engineering. The Computer Engineering program is jointly offered by our department as well as the Computer Science Department. So actually I see on some of yesterday NUS webinar, there are students that ask questions if there's actually two computer engineering in NUS. The answer is no, there's only one computer engineering program at NUS and it's jointly offered by both departments. So you'll spend some time in ECE and some time in the School of Computing. So both of these programs are fully accredited by the Engineering Accreditation Board. And this is something that is important because it means that you go anywhere over the world that is under this Washington Accord, your degree will be recognized, right? And you can practice as an engineer, okay? So without further ado, I would now like to invite Prof. Tam Cheng Kong to share more about the electrical engineering program. Prof. Tam, please.
Thank you very much, Prof. Arthur Tay. Good morning, everybody. It gives me great pleasure to tell you more about the electrical engineering curriculum. You have heard a lot of nice things in the video about what is possible, but let me go into some detail about our curriculum itself. Some of you may have heard the Dean speak about our new curriculum structure, where we actually have a College of Design and Engineering common curriculum indicated in the blue box here. And then we have the major space comprising 15 modules. And then there is the unrestricted elective space where you can actually do a number of programs like minors and specializations. So as this picture shows, while everyone in the CDE, College of Design and Engineering, does the common curriculum, different engineering programs have different majors when the modules that go inside the orange space. But in the unrestricted elective space, you can do anything ranging from a second major, electives combined with a minor, or specializations and so on. And what would guide your choice of program in that unrestricted space, where actually you have a choice of 30 second majors, 60 minors from all around NUS, is possibly the career that you are intending to pursue. So for example, if you have an interest to work on smart device development, you may want to take two specializations, for example, in Internet of Things and robotics, as indicated by the light orange boxes in the top part here. Or if you want to actually do two minors, one in management, one in public health, that would prepare you for a career as a health technology engineer. Or if you want to work in the financial industry, you can take minors in quantitative finance and economics. Or if you actually want to be a technopreneur, like some of the people that were mentioned earlier on, you may wish to do a second major in innovation and design and combine that with your electrical or computer engineering major. So going a little bit deeper into what is the field of electrical engineering about, essentially it is to do with the application of electricity, electronics, and electromagnetism to do incredible things. So electrical engineers design equipment, devices, and systems. And actually, the hardly anything escapes the reach of electrical engineering, ranging from the nano or even picometer scale that you see on the left, in terms of devices like quantum computing that are in the picometer size, to nanomaterials, nano devices in the nanometer scale. Then you have integrated circuits in the millimeter to centimeter scale. And then in the size that all of us are more familiar with, in the 1 to 10 meter range, we have our autonomous vehicles, robots, computers. And then going beyond that, larger systems like our electricity generation grid, which are in the order of tens to hundreds kilometers, and then even the worldwide internet that are in the scale of thousands of kilometers, all rely on electrical engineering principles to come into reality. And then electrical engineering has a long history from the early days of the second industrial revolution in the 1920s. To the invention of the telephone, the integrated circuit and transistors that underpin modern electronics, to diagnostic imaging, the internet, and laser and fiber optics. All are related to electrical engineering. And that's not all, because even in the present and in the future, electrical engineering continues to play a very important role, from quantum computers that you see on the left, to mobile phones, to accelerated machine learning in the form of graphics processing units or GPUs, to interactive robots, to bionics or bioelectronics having an impact in healthcare, to autonomous vehicles, to 5G, 6G telecommunication networks, to the Internet of Things, and even in sustainable energy, such as renewable energy generation. It is, very much to do with the conversion of mechanical energy into electricity. And of course, all of you would have heard about how vehicles are sort of being converted to electric vehicles in order to reduce the carbon emissions of the current generation of cars. So very, very exciting field indeed for all of you to be part of. So, but what do we do in NUS ECE to actually prepare you for such exciting careers? Definitely, you need to be equipped with the right foundation and principles in order for you to work in this field, because frankly speaking, it is not, very, very easy, because advanced knowledge and principles are needed. But not to worry, all of us here at ECE will actually guide you and prepare you for that. So we talked about the entire curriculum, and the blue part, of course, is the common curriculum. that everyone in CDE does, but the engineering major part, most of the engineering programs will do the modeling and simulation, professionalism, and internship. What distinguishes the EE program are firstly the engineering principles and practice modules 1 and 2, which actually give you experiential learning experience right at the beginning. In your very first semester, second semester, you'll be in studios, trying to understand how electrical engineering devices and systems operate, how they may fail and what you can do about it, as well as how they get their energy, how they are controlled, and how do they actually are configured to do useful things. And then we build on that fun introduction with more in-depth modules in electromagnetics, analytical methods, electronic circuits, energy systems, digital design, microcontrollers, signals and systems. And by that time, you would have a pretty good grounding. And then you can take like a couple of technical electives just to round off your basic program in electrical engineering. I mentioned that you can actually go deeper if you wish to do some specializations, take additional electives, take on a minor, take on a second major, and that's what you do with your unrestricted elective space. So going into the technical electives, we actually have what you see here about 9 categories of modules. So you are actually spot for choice. We have this category of foundational modules that build on the core modules. And then if you're interested in communications and networks, we have a wide variety of modules. If you're interested in semiconductors, which is a booming industry, we have a wide range of modules as well. ECE department is a fairly big department, so we do have a very comprehensive set of modules that actually prepare you for careers in pretty specialized areas like power energy systems, integrated circuits, and embedded systems. The IC design industry is a very lucrative one where they are actually have a shortage of engineers. And then control intelligence systems and robotics, signal analysis and machine intelligence covering computer vision, microwave and radio frequency, as well as some up-and-coming technologies such as blockchain engineering. So we currently have specializations in the areas of Internet of Things and robotics, which are actually areas that are very much sought after by industry today. And also data engineering. Data is being generated at very fast rates by people and by sensors and devices, and it is necessary to process and even tease knowledge and insights from these mountains of data in order to guide decision making. So you can actually combine your electrical engineering major with these specializations and this minor. We are going to launch 4 additional specializations. One in Industry 4.0, which is you hear a lot about in the newspapers about how using AI and robotics, it is actually transforming industry. You can also do a specialization in advanced electronics that sort of meet the shortage in chips in the world today. Sustainable electric transportation, how you design electric vehicles, and also space technology, which is actually an area that the EDB and the Singapore government has identified as the next growth area. And it is related to launching or developing and launching satellites that I think you saw in the video earlier on. So our program being so sort of rigorous and also challenging, and developing the right skill sets in our graduates, not surprisingly, has produced some very successful graduates, ranging from Darius Cheong, who actually founded a startup called 10Cube some time back that looked into mobile device security, which he sold for millions of dollars to McAfee, to his current venture 99.co in property. You may wonder what has property got to do with electrical engineering, but what Darius and his colleagues have done is to actually develop very advanced analytics techniques that can match property buyers' requirements to exactly the correct house or factory that they need. So Darius is one of our very successful alumni. And then Teo Swee An, he actually was an undergraduate student in the ECE department in around the year 2000. He did a master's in electrical engineering in the year 2002. Then he worked for a few years. He started his company called Expressive in 2008. And since then, you know, in that span of 14 years till the present, that company has become a world leader in Internet of Things. And he has become a billionaire. And he is named in Forbes magazine. So we are actually very proud of Swee An for his achievements. And then more recently, David Lee, who actually also is a graduate from ECE department, together with a couple of other team members, developed a glaucoma home monitoring device that is very sensitive and accurate. And this won the International James Dyson Award. And Mr. James Dyson himself commended the team for this piece of work. So, you know, with all this current demand in digitalization, electrification, our graduates are really highly in demand. And you can see that from the increasing mean and median starting salaries in the past 3 years. And this is actually significantly higher than another university in Singapore. It can be as much as $600 higher at the starting pay. So definitely a testimony to the quality of our program and the value that employers place in our graduates. So let me finish off by telling you a little bit about a new program, the Electrical Engineering Study Awards. So we have what we call the Shannon Scholar Award, where we are awarding $10,000 to students who join the electrical engineering program. You need to have good A-level, poly, IB, or NUS high school results, and be a Singapore citizen. And then we will give you a $5,000 study award in year 1 and another $5,000 in year 3. If for some reason you do not get a Shannon Scholar Award in year 1, you can qualify for a Shannon Merit Award in year 3 that has a $5,000 award if you manage to get a cumulative average point of 4.5 and are a Singapore citizen. So what are you waiting for? Do come and join us at the ECE department electrical engineering program. Thank you.
Thank you, Cheng Kong. Next, we have Professor Vararaj, who will share with us the computer engineering program.
Just a minute. Thank you, Mr. Arthur. Let me share my screen. All right, so let's directly jump into what is computer engineering. I think I saw 1 or 2 questions in the Q&A, so probably that will also answer this. My presentation will answer this. So what is computer engineering? So we call in NUS it is CEG program. So this is a program that integrates both the disciplines, right? So the computer engineering, so it takes advantage of both the computer science and electronic engineering requirements, right? And you are required to develop the computer hardware and software. So when you walk out of this program, you are trained basically in electrical engineering, the required amount, as software design, and hardware-software integration. So because as you see that these are the things which play a crucial role in any device or any systems that you try to design and develop. And computer engineers in general are involved in many hardware and software aspects of computing. So all the way ranging from design of CPUs and to supercomputer design. And not only that, and CEG is a very focused discipline covering very selected EE and CS topics. So it's just not a kind of a program that can mix both the EE and CS. So it is not a program like that. It's a very, very specially designed program. So as Prof. Arthur earlier said, like in ECE, we offer two programs. Now here I'm here to talk about the computer engineering, which is jointly offered by ECE department and the School of Computing. So you take advantage of both, so you get best of the both. And CEG program is also fully accredited by the EAB. So let's look at the what you do in the computer engineering program, right? So as you see that, like as Prof. Tam said, like in your program has 3 layers, right? So the one is your fundamental, like the first year set of courses, where you learn all about the required fundamentals, and you get exposure even to the modules like project management. So it's like later in industries when you go, you are supposed to have this type of project management exposure. And we are living in the era of big data, right? So big data engineering, as well as everyone talk about the machine learning, artificial intelligence. You get that exposure right at the first year. So the two the modules here, the artificial intelligence and digital literacy, will expose you to interpret the data, how any data would make sense, and also learn about the fundamentals of machine learning. And that forms your first year, the bottommost layer. And then you move on to your major requirements in the computer engineering program, where you will have, right in the first year, you will experience what is called as flipped learning. So it's like you learn something on theory and then bring it to the lab and test it. So this is like, these two modules are kind of very much hands-on. And later I will show you 2 examples of what our guys have done in the earlier batches. And then you will visit all kinds of the core modules which are required for this major. So something like real-time operating system, you get to know about the computer networks, and those who are interested to beef up their programming. So here they have an opportunity to learn the object-oriented programming, and then the electrical engineering-oriented subjects like digital design, digital circuits, and so on and so forth, and together with signals and systems. So this forms your the core major. And as you see that there is also a component here, which is internship. So you have a very unique opportunity to go experience industry work. So this means that for 6 months' time, you go out to the industries, and some of the industries our graduates are looking at as like AMD, the Xilinx, right? Xilinx is now called as AMD, Autodesk, DSO, and many companies, like Micron in Singapore, where they have lots of semiconductor work, well-established semiconductor works. So you have opportunities to interact with industry people. And not only that, if you're planning to go in for a kind of a final year project, or you want to extend the work that you're doing in internship, we have that opportunity too. And the elective space, right? So again, just like what Prof. Tam said, like you have lots of mix and matches here. So you can do 2 majors or 1 major and a minor, or you can use a minor and then specialization, and so on and so forth. So there are literally unlimited pathways. So if you want to be an entrepreneur or a product designer, so you do the basic 15 plus 15 the fundamental modules, and then go in for a major in innovation and design. And if you want to be a data scientist or a biostatistician, then you do a major in statistics. And similarly, if you want to have a robotics major and then an automation engineer, so you do a minor in data engineering and robotics specialization. So there are lots of combinations. I'm just showing you here just 3 examples. So that forms your free space, which gives you room for 10 modules. So you can literally take any mix and match. All right, so the technical electives in CEG, we have organized that as concentration areas. So organization is based on the feedback from the industry people, right? So in department, we have what is called as the department consultative committee. So we periodically liaise with industry experts, and they look at our curriculum and they feedback to us what is important down the road. We look at it of say 5 years to 10 years, which domain is going to get popular, what industry wants, and so on and so forth. So based on their feedback, we organize the modules in these 6 topics. And of course, these topics are subject to change. So tomorrow, so for example, somebody says that like the security is going to be a very high thing, and then probably that's going to be the next 5 years take. Then we are going to use that as a concentration area and put in the relevant modules. But security is also one of the aspects for computer engineering, and you can take modules already available with us. So these are the concentration areas. And if you look at the modules in the concentration areas, these are the ones. But as I said, like the modules are not just limited to this. Okay, so there are other computer science modules and electrical engineering modules available for you to explore. So these are our just recommendations inside each of these concentrations. So let's look at some of the curriculum highlights. So as Prof. Tam said, we have 2 specializations. So these 2 specializations, Internet of Things and robotics, are also available for computer engineering students. So you can explore these 2 things as specializations, and you can also pursue a minor. So 1 specialization and 1 minor is probably the space you have. And then let me highlight on some of the student projects. So in the first year, right? So I said like we have a flipped classroom modules, right? So these are called as the computer engineering principles, okay? Design principles and practice. So there, the students, they do this type of real machines, okay? So these machines, as you see, that these are bots, and these are, and you can put intelligence in that, and all these bots have sensor-assisted devices. So they are deployed to do some kind of work. Say, for example, they can send something on the way, which can be deployed in a rescue operation, right? So this is like a laboratory-based project, and you have, at the end of the module, you have competitions for this. So students in general feel that they enjoy a lot and design as per their learning. So this really gives a feel of both the required electrical engineering concepts and computer engineering concepts coming in play as a hands-on module. And another opportunity where every CEG student will experience is through the integrated capstone module, where in one of the years, I think last year, they have done this project. So you see the guy on the right side, so wearing a red scarf-like thing, and then he's posing something. So it is like actually a dance movement, right? So it's like I'm sure many of you have experienced the device Kinect at homes, right? So we stand before the TV, and then the sensors are tracking you, and then you dance, or even if you have a yoga mat, which can actually, if you stand on the yoga mat and then try to do postures, it can actually correct you and all that. So this is something like that. But now you are in the machine learning era, right? So you are in the data processing era. So what they are doing is that the students are given some movements, and these movements are captured by the camera and the intelligence. And then they are sent to the cloud. So the cloud actually runs a machine learning program. And then if another person comes and tries to do those movements, it can actually correct it. Now, the purpose of doing this is first is like the students really get to know things built from scratch. Okay, so right from the sensors all the way to the programming aspects. And then this is actually the hardware that is doing this is FPGA. All right. So the main thing this is useful for is this can be used as a rehabilitation stuff, right? So where people try to do exercise and the system can correct based on their movements. So that's one experience you will get. And of course, these projects will change every year. All right, and then I'm going to show here some success stories. So this is Michelle Chan, Miss Michelle Chan. So she actually graduated in the year 2016 from CEG, and her passion was in fintech. So she joined Citi as a technology assistant right at the beginning, and then within a matter of 6 years, 5 to 6 years, she's now working in Citi as she's leading a team as an application developer. And then Mr. Baron Chan, I think 2018, graduate from CEG. So he's now working in Ninja Van. He joined Ninja Van, and his work is to support the last mile delivery skills, right? So it's like he develops the apps, and then what they call it as like service-oriented solutions, like the architectures for the company, which helps them to maximize the revenue as well as brings them high level of customer satisfaction. And definitely, most of us have used or are using Carousel, right? So that Carousel, one of the founder members is Lucas. Mr. Lucas is the guy in the middle. He graduated in the year 2012, and he founded Carousel in the year 2012. Okay, so Carousel, like it's like a market known all over Asia, and it's even trying to penetrate the North American side now. And he has obtained more than 7 million in seed funding. Right, so he's one of the very core contributors of the Carousel company, and so these examples show you like you can actually divert your passion with all your learned soft skills to be useful to the society in your careers. So with that, similar to EE, so we have a graduate employment survey, which gives a very high level of satisfaction for our graduates, as well as the industry wants NUS graduates here. So if you look at the median salaries, these are quite attractive here. And as the time grows, you see the median salary also increases. So that's one of our major success in this program. Actually, one of the Q&A which one person has raised, like is programming a requirement or something like that, I would say that you will learn everything from scratch. So if you have the right mindset to learn, I think you are most welcome in the computer engineering program. So I end my presentation here. So let's stay healthy. Thank you.
Thank you, Pradeep. So next, let me share my screen.
Oops, 1 minute.
Yeah. Okay, so just now, Professor Pararaj and Prof. Tam have shown you some of the projects that our students do, right, over at the department. So now I'm going to show you a few more of these projects.
We go quiet and let you have a feel of the launch.
So the first one that I have here is the Nano Satellite Education and Research Program that we have here. So over here, we have students from electrical engineering, computer engineering, and even mechanical engineering gets to work on these projects. So they work towards a launchable nano satellite. Students can also try to apply for your own internship, like some have gone for NASA internship, exchange program with other universities. And they actually build satellites that is actually launched into space, right? Like it's shown over here at this video.
7, 6, 5, 4, 3, 2, 1, 0. That's 1. PS1 ignited. 3, vehicle lift off normal.
So I do encourage whoever that is interested in maybe space technology to join us in this program. The next launch, if I'm not wrong, will be next year. And there's also other scheduled launch. And our undergraduate students, you get to see your own satellite in space and sending down data on a daily basis, right? So we have this Star Satellite Technology Center, where there's actually a control station where you get to see all the data and sensors information that is being sent down to the station daily. Another project that our students get to work on is this Team Bumblebee program. It's a multidisciplinary student team. Again, you have students from electrical engineering, computer engineering, mechanical engineering working on this, and they try to solve many problems, right? There's a short clip here that I can share with you.
One of the main challenges of designing an autonomous system is knowing what you should be doing at the right place and at the right time. If we are just dropped into this competition, we should be able to go and do at least a few tasks without me having to code anything. That is actually very difficult to do.
The technology that we develop, the knowledge that we learn, I believe one day itself will actually be used in discovering something unique in the ocean. The ocean is just out there for us to discover. We just need more of this competition and talent.
So again, the Bumble Team, B team actually starts recruiting students when you're year 1, and for those who are interested, you can sign up and work with them.
General Hospital,
we also have students that work on healthcare projects, right? So over here, it can range from the more on the healthcare data analytics type of projects to more on the hardware type of project. Just now, Prof. Tan talks about IC design. So over here, there's a wireless ECG monitor that is actually developed by students, right? So that requires skill sets from IC design, right? And then over here, we have what is called a telehealth project. And this is a very interesting project because we actually have students from electrical engineering and students from computer engineering that they come together, develop this solution that's then roll out nationwide to all public hospitals that allows patients to do rehab exercise at home, right? And they actually started a company to do that.
Sign up for telerehabilitation. It's a low-cost program that uses real-time video conferencing, allowing therapists to treat and communicate with patients in the comfort of their own homes. The program is a result of a collaboration between the Singapore Millennium Foundation, the National University Hospital, Singapore General Hospital, and Ang Mo Kio Tai Hwa Kwan Hospital. Patients do exercises prescribed by therapists by following videos they can view on their iPads. Sensors are attached to the patient which transmit data and their progress via Bluetooth to the iPad. Therapists can find out if their patients are doing their exercises correctly and inform them if they're not. They can also check for anomalies using the data or watch recordings of the exercise.
Right now, so something like this actually requires many skills that you learn from the electrical engineering as well as computer engineering program. One of the things about studying engineering is, we get to develop solutions that actually solve a societal's need, right? So our electrical and computer engineering students also contributes to COVID-19, right? So during the circuit breakdown, we actually went into the workers' dormitory, right, to set up an automated system that can track their blood oxygen content, right? So I think most of you would have received this pulse oximeter from Temasek Foundation, right? So in the workers' dormitory, what happened is that when they click on to one of these devices, the data is automatically uploaded to the cloud, and then we perform data analytics to alert, their manager that maybe this particular worker's his symptom has worsened, or he might have some COVID symptoms, etc. Right? We also have many double degrees, major and minor programs, right? So for engineering, you can do a double degree with business administration as well as economics. So you can actually select this at the point of admission or at the end of your first year with us. We have more than 30 major and more than 60 minor and specialization programs. So you can scan the following QR code to take a look. Over here in this table, I've listed down some of the possible major and minor program with the electrical engineering as well as computer engineering program. Now, if you go and click on inside the registration portal, right, you might see that the number of major and minor at the point of admission is very limited, right? But actually, there are many other majors and minors that you can select once you have joined NUS, right? So once you join NUS, you can select other, because those are the open type that you can just choose what you want, okay? So these are some of those. You can scan the QR code and then try to understand a bit more to see what you're interested in, right? Sometimes we might not know what we are interested in at this point in time, right? But there's still opportunities after you join us. And just now, we also talk about student exchange program, right? So before COVID, most of our students get to go for student exchange program. I think different countries are opening up, and some of our students have actually started going for overseas exchange program again, right? So we have more than 100 partner university worldwide. We are also the only university, right, engineering school in the world that have exchange program with Oxford and Cambridge. And another unique thing about NUS is that we have this NUS Overseas College, right? So for those of you here that are passionate about startup entrepreneurship or technopreneurship, you can join one of the NUS Overseas College, right? You get to intern at a startup company overseas. So for example, if you do electrical engineering, then we can match you up with maybe a startup company in Silicon Valley. So you'll go over there, work 1 full year as a full-time employee in the startup company and learn all the hands-on experience, have all the hands-on experience and skill set to do startup, right? Of course, if you go 1 full year, then you will delay graduation by 1 whole year, right? So what happened is that you will then study at the partner university. In this case, if you go to Silicon Valley, it will be Stanford, right? And then so that when you come back, graduation might still be delayed by about 6 months, right? Depending on how fast you progress, right? But at least those modules that you take at Stanford can then map back to NUS. So currently there are these are the different locations from New York, Shanghai, Silicon Valley, Stockholm, Canada, and different places, right, that you get to choose to go to. And so just now, the two professors have actually shown you some of the successful alumni that has gone through the NUS Overseas College program, right? So we have Darius Chung over here from the electrical engineering program, and then Lucas Neo here from the computer engineering program. So I'll not go further into that. So our students actually gets to work in many different areas. So these are just a snapshot of some of the companies that they get to work in, right? So for I think many are now with Shopee, Ninja Van. So these are, you know, because of COVID, many people have buy things online and they need a lot of skills from computer engineering as well as electrical engineering, right? And of course, there's the more traditional defense industry, right? The research industry, all the way to your Google, Facebook, Microsoft. Chemical industry also employ many of our engineers. The semiconductor industry requires a lot of engineers nowadays. And so nowadays is very different from last time, right? In the past, when you talk about semiconductors, many of you would have the idea that you need to wear up a bunny suit, go into the clean room and do all sorts of things. But now most of this industry has been automated. So they are what we call lights off industry. If you go to visit them in the wafer fab, it's all lights off. So all the engineers are actually sitting in front of computers, understanding data, you know, developing solutions to solve problems, right? And so I encourage you to scan this QR code to find out more about programs from our website, right? You can also call us or email us. I'll flash these slides again later on. So now I want to let Dr. Chua Ting Jen to share with you some of the vibrant student life activities that we have within our department. Dr. Chua, please.
Thank you, Prof. Day. Can all of you hear me? Yes, okay. Hi everyone, good morning. It's very good to see all of you here today. So my name is Ting Chen and I'm the Associate Head of Student Life. So I'd just like to take this opportunity to share some of the exciting things that our students do outside of class, okay? So NUS is a really big place, and under NUS Office of Student Affairs, we have Student Life, and just student organizations in NUS itself. There are over 220 student clubs and societies to make sure that all of you will find a group or a student interest group that is aligned to your interests. So these student societies are really wide ranging. So you have things like anime, you have things like gaming, you have things that are religious. So it's really about bringing together with students with common shared interests. So apart from enhancement programs, there are also things like residential life. Okay, so residential life will make up a good portion of your student journey here if you decide to stay on campus. So there are a lot of activities as part of residential life as well. So one thing different about our department is that our department itself also has a student life office. So we set it up in 2012, and under our student life office, our goal is to make sure that we augment the efforts at the university with specific efforts targeted at our electrical engineering and computer engineering students. So we hope that some of you don't forget that there's life outside the classroom. We're trying to provide you holistic and rich experiences beyond the classroom. We hope that through all of the activities that we do, augmenting the activities that NUS already have, you will build a strong sense of community together with your classmates, together with your cohort mates, together with your department friends. Okay, so when you go out to work, you can say that I have a group of friends, be it computer engineering students or electrical engineering students from my uni days, that you can reach out to, you can network with, you can talk to about your experiences, right? And we also hope that through our student life activities, we will prepare you as all-rounders for life after graduation. So some of the pictures here that you see are from graduation. On the bottom right, we see a really lovely picture of our students during our graduation event. So this was pre-COVID, all the masks were off, right? So if you bottom left, you actually see a group of our students from the Undergraduate Student Council, okay, who went to Soup Kitchen Willing Hearts to volunteer. All right, and right in the bottom middle is basically a snapshot from orientation activities. Okay, so how do we try to support your student life here? So there are three main aspects. We look at academic advising, industry exposure, as well as student welfare in the aspects of counseling. So in terms of academic advising, not only do we have a student portal, we have actually a huge group of staff and officers, or basically people to support you in your academic journey, right? How do you plan your work? How do you, we also have a academic advisor who is tagged to you when you enter our programs. So the academic advisors will kind of accompany you and follow your journey as you go throughout your 3 or 4 years. Okay, so in the bottom right, you actually see our freshman party, okay, where we find a large space and put together our students and their academic advisors and allow them to interact and get to know one another. And of course, all of this is not possible without our student support managers and many other officers within NUS, like OSA, we have counseling services, we have our health center to support students at risk. Okay, so as you can see, I hope you can see that at NUS, you have a lot of opportunities to pursue your interests, to pursue, be it academic or extracurricular. A lot of it is about you, taking the time to explore, evaluate, and then, see which are the things that, that align with your interests, that are the things that you want to invest your time in. So apart from academic side of things, we have 5 student groups that work very, very closely with our department, specifically our Undergraduate Student Council. We have our ECE club. We have 2 IEEE affiliated student groups, which is Student Branch and a HKN chapter. All right, and we have a new student group coming up, which is the AISG, all right, which stands for basically AI.SG. All right, student chapter, which is upcoming. So one thing that I want to add on is that a lot of our activities are actually student driven and student led. Okay, so a lot of these activities, students will poll their friends, think about what their fellow classmates would like to participate in, what they have interests in, and then they will go on to organize these activities. So right here you see actually a workshop for the AWS Deep Racer workshop. Okay, so this is actually this was actually organized by the IEEE NUS student branch. Okay, we have orientation activities, we have carnivals, welfare pack giveaways. So there's really a lot of activities that our students organize for their fellow community. Okay, so the last, this is my final slide. So the last thing that I'm going to talk about is not only do we support academic and extracurricular, okay, we also try to support the industry exposure and career planning aspects together with the NUS CFG group. Okay, we organize activities that are specific and tailored for electrical engineering and computer engineering students. So we have industry talks and visits. We have networking sessions with companies. Okay, we have our flagship event, our ECE Internship and Career Fair. Okay, so right here at the bottom, you see our ECE Career Internship and Career Fair poster. So this year, our students organized a hybrid fair where we had a physical session and a virtual session on Zoom, and they managed to have over 40 companies come and join us for our event here. And all of these companies have employment opportunities specifically for both electrical engineering and computer engineering students. So you can see that, the industry is actually very, very receptive of our graduates. All right, so on the top right, you see we had a recent technical webinar on cloud architecture, and this was hosted by VMware. So VMware, if you're not familiar, they actually were part of the group that developed the Trace Together technology. Okay, so they're actually a very quite a well-known cloud technology company. Okay, so I'm going to hand over to our students who will share more of their experiences from here. All right, so if you guys have any questions, please feel free to ask. Thank you.
Thank you, Ting Jian. Now I would like to invite our EE1 student Hui Yi to share with us her experience so far. Hui Yi, please.
Okay, hi everyone. Can you see my screen?
Yes, Hui Yi, you want to on your camera?
Okay, just give me a moment. Okay, sorry.
Thank you.
Sorry, there's like some technical difficulties. I can't really on my camera. Is it okay if I proceed like that?
Yes, please continue.
Okay.
Thank you.
Okay, all right. Hi everyone. My name is Hui Yu. I'm a year 1 electrical engineering student, and I have a major in sociology. Personally, I think this is the most attractive part of uni education, where we can actually personalize our degree and freely explore different topics of interest. So I remember the first lesson I've ever attended as an EE student. The professors told the entire class that they will not be teaching us. They emphasized that we will be provided with the readings, and we as students should do our due diligence by reading in advance and prepare for class discussion. I remember being so surprised by the sudden announcement, and this was not how I imagined uni would be like. And to my surprise, I enjoyed this kind of flipped classroom learning, and I find the discussion extremely productive and meaningful because the students come to class prepared with questions. And if this sounds scary to you, fret not. This is just one of the many different teaching styles that they have in NUS while the school tries to engage students in their learning. On the same note, most of the subjects, or what we call modules, are conducted in the lecture tutorial style, which I believe most of you guys are familiar with. So far, uni has been really exciting, where I get to study different modules from different disciplines, such as computing, design thinking, etc. It is also really intellectually engaging and challenging. I remember that there was this module, EG1311, where I built my first ever robot, and I made a paper wallet in 5 minutes, and I built 20 electronic circuits. I think being in uni is also a lot about being self-disciplined and self-directed when it comes to your own learning. because everyone is being taught the same thing during lectures and tutorials. So my question is, what makes you stand up amongst the rest? Now we move on to the more exciting part, the NUS student life. So before I even matriculated into NUS, I participated in 4 NUS camps and participated in 2 RECs, which is also known as Receive and Give. There's some type of charity dance, and it's also a sort of freshman orientation program. I'm also really lucky to be able to stay on campus. Currently, I'm staying in Yusuf Hall. We have about 6 CCAs, and I play sports and perform. I also host events in Yusuf Hall. Hall life is really vibrant and filled with fun-filled activities and supportive peers. So beside Hall, I'm also part of the ECE Undergrad Student Council, which is also known as USC. And one of the events I did this year is the Internship and Career Fair. Overall, I think that the NUS student life is really exciting and full of new opportunities. I believe all it takes is some courage to sign up and you can get to experience new things. And personally, I think that you are in the really lucky batch because we are slowly transiting back to the new normal with lesser COVID restrictions. And this also means that we can expect a more vibrant student life with real-life CCA, camps, and physical lessons. And that's the end of my presentation. Thank you so much for your kind attention.
Thank you, Hui. Next, we have Yu Jie from Computer Engineering that is going to share with us his experience so far in NUS. Hi, Yu Jie, please continue.
Hi, okay, give me a while. Okay, so hello everyone. My name is Yu Jie, and I'm a Year 4 Computer Engineering student. So today I'll be sharing with you a bit more about my student life in NUS, so you know what to expect in your 4 years when you enroll in computer engineering. So now, why did I choose NUS? I think the great thing about the Electrical and Computer Engineering department is that there's a wide variety of modules for students to choose from. So in my year 1, there was a preparation module called CG 1111, where they taught us basic programming skills and engineering practices. Then in the later years, ECE has also offered me modules which allow me to develop my interests, such as machine learning and Internet of Things. And both of them are actually very relevant in the industry. So in the picture on the left, we developed a wearable which used machine learning to detect what action the user is taking. And on the right-hand side is actually a very cool robot which uses LiDAR technology to navigate a maze remotely. So LiDAR is actually one of the technologies currently being used, such as in robot vacuums and even in some of the autonomous cars out there. So, well, I mean, university is not just about academics. So during my 4 years in uni, I joined the NUS ECE Undergraduate Student Council, where I served as president for 2 years. And during my time there, I organized school events such as the Freshman Welcome Party, which you can attend when you join us, as well as others such as the Internship and Career Fair, which Hui mentioned, and the Graduation Farewell Party. So I was also the representative for my cohort during the Student Staff Liaison Committee, where we raise feedback to the department so students can have a better learning experience. And during my school term, I also applied to be a part-time teaching assistant, where I taught my fellow peers on data structures and algorithms, as well as basic programming methodology. I also went on 2 internships at DSTA, where I worked on a natural language processing project in year 3, Sem 1, during my industrial attachment, where I got to apply my machine learning skills on a project, and on a DevOps project in the summer holidays, where I got to apply my software engineering skills, both of which were modules which were offered by ECE. During my year 2 Sem 1, I also went on a winter exchange program for 2 weeks, where I got to experience what life is like in another country and in another university. So I got to explore different parts of Korea and even learn Korean from the university itself. Well, now you know, you must probably be thinking, it sounds like a very daunting task to be in uni. You know, there are so many things you have to learn and so many activities to do. So, well, here are some tips which I feel are important when it comes to surviving uni. Firstly, time management is very important. In uni, the timing of the lectures can vary from morning to evening and sometimes even night. However, it is important to ensure that you plan your time properly, such as, you know, when to complete assignments and keep track of deadlines. Secondly, I think inquisitiveness is important too. Being inquisitive, it doesn't just mean asking questions in lecture. I think that truly being inquisitive means finding out the answers using any resources available to you. Before I started my uni, I absolutely hated books of any kind. Okay. However, nowadays I find myself reading up on resources from books or even Google whenever I have a question on any topic. Lastly, I realized that friends and networking are absolutely essential in university, especially in a time like COVID, where most of my lessons are at home. I find myself missing the times where I would meet up with my friends for lectures and have meals together. Having friends also means having a pillar of support when the times get difficult. Friends also mean that you have someone reminding you of deadlines or even someone to help you with your homework. I would like to end off with a quote. When the going gets tough, the tough gets going. I assure you that there will be tough times in your upcoming journey ahead, but the ECE department is truly one of a kind in terms of the culture. We have some of the most friendly profs around, such as Prof. Atate, Prof. Tam, and Prof. Chua. And I'd like to highlight that no matter what you choose, it is very important that you make full use of your 4 years in uni, experience the most while you can, and lastly, have fun. So this is the end of my sharing. I hope I gave you some insight into the life of a CG student. Thank you.
Thank you, Yijie. Next, we have Terence, who is our EE alumni and currently working at ESO. Terence, you can start sharing.
Hi, I'm Terence, and today I'll be giving you some reasons why NUS ECE from my perspective, from my experience after graduating from the program. So firstly, I'll start with a brief introduction about myself. I did electrical engineering with a second major in business analytics, and I graduated in 2020. So during my time in NUS, I've also done an exchange program at the University of Oxford and summer schools at the 3 places as shown. I've also did 2 internships in computer security and investment banking. And outside of my academics, I've also participated in a couple of CCAs. And I'm currently a data scientist at ESO National Labs. So firstly, why NUS and why ECE, right? So NUS ECE actually has a world-class curriculum, and this is spoken from experience. There's a flexible curriculum with option of many majors, minors, second degrees, many combinations for you to choose from. I was the only person in my cohort who took an electrical engineering and business analytics combination. And this interdisciplinary curriculum actually allowed me to carve a niche area for myself, and that is difficult for others to compete in. And this actually provides me to have a unique value proposition that makes my skill sets attractive to companies. So and the NUS ECE curriculum also provides a wide range of modules for you to choose from, as mentioned, including graduate modules and research opportunities. So for example, I took a machine learning module with the PhD cohort in my second year, and this actually equipped me with knowledge on the latest research to speak about during my interviews with companies. And just after 1+ years of university education at NUS ECE, I was able to land 2 full-time job offers in my second year. So besides that, the NUS ECE program also provides you with many extra certs in industry tracks in the latest trends such as AI, 5G, renewable electric vehicles, advanced electronics, and so on. So if you are interested in all these areas, the NUS ECE program will be the place for you. And all these extra certs and tracks, these are not purely certifications, but these are actually modules that will equip you with the skills and experience required for you to thrive in jobs of tomorrow. And yeah, so there are so many opportunities and so many options to customize your education at NUS, and it's really up to you to make the most of it. So the second reason about why NUS is because NUS is simply in the middle of the tech hub, not only in Singapore, but the tech hub of Asia. So you have proximity to many top companies, such as Grab, Razer, A-Star, Shopee, and so many other companies. As you can see in the Cambridge region, you are just next to Science Park, you are next to Maple Business City, One North District, Buona Vista, which has so many tech companies. And from my experience interviewing at companies, this proximity actually makes it so convenient for you to attend workshops, attend events at these companies, go for your interviews, and come back for lessons in the short breaks you have between periods. The third reason, so of course, I believe many of you are considering the brand name and rankings. So NUS ECE is actually one of the top in the world, not only in terms of the school ranking, but also in subject rankings as well. And this reputation actually extends overseas, extends to many top companies and top universities if you want to pursue graduate studies. And this is coming from experience when I went overseas during my exchange and internships at these many other universities, that when I tell people I'm from NUS, people actually look at me differently, and this actually opens many doors for you. And this reputation is also because there are many NUS students who have gone before you to top companies and these top graduate programs, and they do well there. And so they paved the way for you. And besides that, NUS ECE is also special in a way that we have honor society. So we have this HKN honor society, and this is only available to 2 schools in Singapore, one of them being NUS, and only 2 programs in Singapore, one of it being the ECE program. So, and my fourth reason is that if you come to NUS ECE, you actually get to have a global education on local fees. So by paying local, highly subsidized Singapore school fees, you can actually go on programs to other universities, going overseas on SEP, NOC, summer programs there, and etc. So for me, I have been to an overseas summer school at Hanyang University. So on the top left, you can see a picture of me and my friend at the Hanyang logo. And on the top right, you can see a picture of me with fellow exchangers from different universities in Korea, but with a common similarity that we are all from NUS. So because NUS has so many opportunities for so many students to go abroad, you can actually very easily find travel buddies who are also from NUS. And this picture is when we took a road trip through the length of Korea from Seoul to Busan. And the next, another overseas experience I had was during my exchange to the University of Oxford. So as mentioned just now, NUS Engineering is the only place in the world with partnerships with both Oxford and Cambridge. And Oxford only has partnerships with 2 schools in the world, Princeton and NUS. So if you want to have an opportunity like this, NUS ECE is the place to be. And of course, there's no going away from student life at NUS. So this is a picture of me leading an orientation group at one of the orientation programs. So some programs, as you can see in the curriculum, some programs are closed off from the rest of the school, like they're only in their own faculty. But at ECE, you are not only part of the ECE and CDE community, you're also part of the larger NUS community, and you are able to take modules from everywhere. You have so many opportunities to interact with so many others outside of your discipline through academic modules, through the many clubs and societies that you can find at a large university such as NUS. The student life at NUS will enrich your university experience. And from personal experience, this is an opportunity for you to help you expand and foster your close circle of friends who eventually become your support network and help you excel and help you make the most of your university experience. So I've come to the end. This is my email. Feel free to contact me if you have any further questions. Thank you.
Thank you, Terence, for sharing with us all your interesting experience that you had while you were with us, and now that you are working as a data scientist at DSO. So we still have a few minutes that we'll try to answer some of the questions that you all have posted online. So one of the questions that I've seen over here is it possible to do electrical engineering and a second major in computer science? So this is not available because there's a lot of similarity in terms of the modules and programs within electrical engineering and computer science. So right now, you cannot do a second major in computer science if you choose electrical engineering. And then there's a question on, for electrical engineering, will electronics and coding be covered, and how much are they covered, right? So maybe I would like to invite Prof. Tam to share with us a little bit about the curriculum.
Yeah, so actually, when you say coding, you mean programming, and due to the prevalence of computing in all aspects of life, not just in computer science or computer engineering, but in business, in electronics systems, healthcare systems, and so on, it is very important to actually have coding experience as a graduate in any field. But I think it was mentioned earlier, not to worry, because we do not assume any prior coding knowledge or experience, and we will actually develop and guide you from the basics, the foundation, from the very first year, first semester, and then gradually build up your competency in this important area over the years. So naturally, in computer engineering, there will be more programming involved due to the fact that the computer engineering program deals more with computers. But I hope you would have gathered from the presentations earlier that electrical engineering is a much broader field because it includes areas like communications, electronics, as well as data analytics, and so on. If you talk about things like an electric vehicle, the part that propels the car is actually electrical drives, electrical motors. This is what makes Tesla cars accelerate incredibly rapidly. Not just Tesla, but other electric vehicles from Porsche or Mercedes and so on. If you just do programming, obviously that doesn't make a car. But if you combine a very powerful electric motor with programming as well, you can actually have a wonderful experience in terms of a car that accelerates incredibly rapidly, gives off very little carbon dioxide, as well as have fancy entertainment systems, navigation systems, and so on. So both EE and computer engineering programs will actually develop your skills to make all these wonderful experiences possible. Thank you.
Thank you. There's also a question that asks about whether there are other specializations other than IoT and robotics, and whether if you can apply after being admitted to computer engineering program.
Yeah, I think I'll take this question. Please don't get the impression that there are only 2 specializations for computer engineering. The specializations that I talked about for electrical engineering, such as Industry 4.0, space technology, as well as advanced electronics, are also open to computer engineering students. The only one that is not open to computer engineering students and only for electrical engineering students is the sustainable electric transportation. And one reason why that is only for electrical engineering students is precisely this thing about electrical drives and motors that we cover in quite great detail in the electrical engineering program and not so much in the computer engineering program. But in terms of the other specializations, they are also open to computer engineering.
Okay, thank you. Next, there's a question on, do you need any prior experience in programming and coding to excel in either the electrical or computer engineering program? Maybe I can invite Prof. Barraj to say a few words regarding that.
Yes, thank you. Yeah, actually, as I think Prof. Tam has already answered that question in a way, and I think I also told that in the presentation. So there is no expectation in the prior knowledge. So here, right at the first year, you are trained and you are exposed to the right amount of programming required for you to go through the program, I mean, the curriculum. Secondly, as a computer engineering student, you will have other opportunities to learn programming in other modules. So there is no prerequisite knowledge required right at the entry level. So that would be my answer.
Okay, thank you. There's a question that asks if I want to do banking and finance in the future, which engineering program should I apply for?
Wow. So I think I can answer that. Okay. I think we had a success story which I told Miss Michelle T, right? Michelle T, who joined in City. So that's from FinTech. So as you see that like the program just not only caters to the nuts and bolts of computer and then you program it. So if you have passion in art, digital art, right? So who knows that like if you have a digital art, I mean you can develop NFTs and then you can sell it online like a crypto. So these days are possible, and that's all due to the programming and all that, right? So if you have the right skills, I mean, what both the disciplines attempt is that they mold you and train you in the required skill set to face the careers. So it's if you are interested in fintech, yes, I mean there are lots of students working in fintech IT companies and all. IT divisions.
Actually, the same applies to electrical engineering as well. We do have many electrical engineers that are working in banking industry as well. So the real thing is that over here at the department, we actually train you, how to solve problems, right? Given a problem, how do you solve it systematically? How do you look for solution? How to get the necessary skills to address those issues. And those are things that actually the employers out there look at it, they value those type of skill sets that our students have. Right. And so I think there are many industries that you can join, right? As long as you learn all these important skill sets, I think it will help you to excel in your career next time. So I think we are coming to the end of this webinar session. So if you have more questions or want to talk to our professors or our students, I do encourage you to sign up for next Saturday, 5th of March, face-to-face event over at NUS, right? You can go to the CDE website, look and sign up for the time slot that you are interested to join. Before you go, I would like to get your feedback on our session, and so I'll put this QR code up here. You can scan the QR code and give us our feedback so that we can continue to improve our program and sharing session. Okay, once again, thank you very much. I would like to thank our panelists, our head of department, as well as our presenters, Prof. Tam, Prof. Barraj, Dr. Chua, our two students, Yijie and Hui Yi, as well as very thankful to Terence, our alumni, for joining us this Sunday morning to share with us his experience over at the EE department. Okay.
Right. Goodbye, everyone, and have a nice day.
Goodbye, everyone.
Thank you.
Thank you very much. Thanks for joining us this morning. Bye.